Hello, everybody. Blue Thunder here. Welcome back to LeetCode Contest Corner. This is week 351. This week was pretty. It was still a little tricky this week. I only got one problem done. Uh, I made some headway into the second one, but I couldn't do it. So we'll get into that. First, let's congratulate Uh, denial. I think that denial. You can't. There's no e. You got to denial. No e. Make sure you don't say the e in there. 13 minutes. All right, fast dude. Um, so yeah. All right, number of beautiful pairs. All right, think of the most beautiful couple you can think of, and then throw that away because it has nothing to do with this. All right, I'll read this as usual. I'll read this and I'll explain to you how what what it means and how I did it. All right. So you are given a zero-indexed integer array nums, a pair of indices I, j, where where 0 is less than or equal to I, which is less than j, which is less than nums.length, is called beautiful if the first digit of nums I and the last digit of nums j are co-prime. Return the total number of beautiful pairs in nums. Two integers x and y are co-prime if there is no integer greater than 1 that divides into both of them. In other words, x and y are co-prime if greatest common denominator of x and y equals 1, where greatest common denominator x and y is the greatest common divisor of x and y. Okay. So this isn't the. It sounds a little. Maybe this sounds a little scary, but it's not too much. It's just really long sentences. All right, it's not that bad. Okay. So this first part here, I don't know if you guys watched any of my previous videos. Zero indexed array. That means it's an array that starts at 0, like most default arrays, as far as I know. Um, it's not like I guess like I'm gonna my programming teacher's gonna kill me. What you call it? It's like you pop in or pop out. I know how to make it, but I don't know how to what it's called. It's like special kind of list. Whatever. It's not that. It's an array. All right, that's what that is. Okay, and then um, this is just I guess it's just the mathematical way. So basically, okay, we're trying to find a beautiful pair. So it's a pair. So it's two numbers in the array, and this part is just saying like it can't be the same number. So obviously, so yeah, that's yeah. So then we're trying to find beautiful pairs, which means I don't know if this is a real thing or if LeetCode made this up. I've never heard of beautiful pairs. I'll have to maybe look up that up later. Um, but so at least according to this, a beautiful pair is when so let's see, I guess I'll open up the code here. Okay, a beautiful pair is just saying it means uh, okay, so it focuses on the first digit of the first number and the last digit of the second number. So we're ignoring. I'm trying to make this a 4. We're ignoring the 4 and the 2, okay? Um, we're looking at the 1 and the 3, and this is a beautiful pair if 1 and 3 are co-prime. And they're co-prime if basically if they, if they're don't divide into each other, which since one of the numbers is 1, then it can't be co-prime, which is weird. So I don't know. Let's think of another number like 7. Yes, three can't go into 7. 2 can't go into 3 or 7. 1 can't go into 7. then obviously anything bigger than 3 can't go into 3. So those two numbers are co-prime. No numbers can go into them. So these numbers are a beautiful pair. Like I said, I don't know if that's a thing that you know, uh, if I don't know if that's a real thing. Is what I'm saying, but I guess that's what we're dealing with. So that's what that is. Okay. Um, yeah, and greatest common divisor. You know, if you don't know what that is, if that's not ringing any bells for you, uh, I don't know how you would even understand most programming stuff. I'm sorry, but yeah. So it's just the greatest number that the biggest number that can divide into both numbers. So yeah. All right. So then the constraints. I don't think there's something too interesting here. Okay, nums length. It always has at least two. The biggest it can be is 100. It's I guess if it got super big, it would make my program run a little longer, but it wouldn't really make a difference. And then the number, be any number. This definitely doesn't matter. Just be any positive number. Um, so yeah. And then nums I mod 10 does not equal 0. Uh, okay. I didn't look at this. Uh, this doesn't appear to affect anything. Okay, so I'm looking. I think this just means there's no numbers in the number array. There's no ints that are divisible by 10, which, okay. uh, oh, okay, all right, because that would mean that one of the numbers, like, okay, because that could have been the last digit, right? This could have been if it didn't have that constraint, this would have been 0. I don't know if that would have affected anything I did. Probably would have, because we're dealing with like greatest divisors, greatest common, what you call it. So that's actually really helpful. I didn't think of that because we could have had dealt with 0, which is not. You can't. Well, you can. No, I guess yeah. It could have because yeah. Okay. All right. We'll get. All right. Let's get into my code. See how I did. How did I count all the beautiful pairs? Um, because yeah. All right. See if you look at this. There's 5 beautiful pairs in here. 2 beautiful pairs in here. If you want to see the explanation, it says which ones are beautiful pairs. Um, yeah. So how did I do it? It's pretty much just a check everything process. So all right. So we start the method here. We got beautiful pairs. This simply counts how many pairs we've got so far. So we start with 0. Then we got this for loop. This is so yeah. This is I deal with I and j, same as the description of the thing. Um, uh, so if we have right here, like right here, we have this array. I will go through all them. It will go through 11. It'll be 21, and so then we'll get so when as we loop. So we'll start. Okay, we have the I for loop here and the J for loop here. We'll loop through all the numbers like this. We start here. I is 11, and then J will loop to 21, 12. Then I becomes 21, and J will be 12. It'll just be 12. And then that's it. This is pretty small. I'll make it bigger here. Maybe it'll 4, 7. Okay. So just try to make sure I'm explaining everything. So I will be 11, then J will be 21, 12, 3, 4, then 7. Then we'll make I will be 21, then J will be 12, then 3, then 4, then 7. And I will be 12, then J will be 3, 4, then 7. And I will be 3, and I will be 4, then yeah. So yeah, I think that makes sense. I hope that makes sense. All right, so then, um, okay, we got these. These are also pretty simple code. Maybe it looks a bit beefy, but it's pretty simple. Initially, so these, okay, so what these do, I'll just tell you what these do first, and then I'll tell you how I do it. These two blocks of code here this one gets the first digit of the first number, um, of I, and then this one gets the last digit of J. Um, Initially, I had this block of code right here, which was fine, I think. I think it would have worked perfectly fine. But as we loop, I would have been the same as we loop through J. So I was just like, oh, this is going to be running on this, it'll run this line like a bunch of times for no reason. So I was like, okay, I'll throw it up here for some like, uh, whatchamacallit, just more efficiency. Yeah, it's more efficient. Only run it once. Um, so then, okay, so this is fairly simple. So we start line by line. String. So first I convert the number I that we want to look at. I convert it into a string. I put it into, I call it first digit S. And I forget after this, I kind of forget about num1 and num2. I have the first digit and the second digit, or the last digit. It's pretty, because yeah, it's same numbers. That's what I refer to them after this. The first digit, and so I just put the number into first digit S. I convert it to string just by adding an empty, concatenating an empty string to it. So then first digit S, I just get the substring 0 from 0 to 1, which just basically give me the first letter, or the first whatever, the first character, but it's still string to be clear. Give me the first one, which in this case would be the first digit of the number. All right, so that's in first digit S. And then, so I got that number, but it's a string, so I parse that string into an int, parse int. So we got the first int. I called it first int. That's, all right. I don't know why. All right, so I guess I called it first int. I should have maybe called it first digit, but it doesn't matter. But all right, I call it first int. And then down here is the same thing, last digit, make it into a string. And then here uh, I got the string dot length -1 and string dot length. So that gets me the last digit. That's where you find the last digit. And then parse that last digit into last int. And there we go. We got first and last int. Um, all right. So we got the digits. So then I check the first int, first digit, see if it's bigger than the last int, the last digit. This this is okay. So now we got two digits, 9 and 5. Um, so we want to find the greatest common denominator. Now we could just maybe I didn't really think about it. Um, Maybe I could have done this, but we could just go like start from 9, go all the way down to 1, go all the way down to 1, and then yeah, check if there's any common divisors. However, um, bu- 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 however, all numbers bigger than 5, you know for a fact they're not going to divide in 5 because you can't put any number bigger than 5 into 5. So this part checking if I'm finding which number is bigger so that I can start from the smaller number. So in this case, we start if the first int is bigger than the last int. And then we start with this Boolean. Um, all right, I'm back. Sorry about that, guys. Anyways, so as I was saying, we're dealing with the case where the first digit is bigger than the last digit. Um, uh, so sorry, get back into it. So we keep in track if they are coprime, we're going to assume it's true, and if we find that's not true, we'll change this. That's what that is coprime is about. So then we have this for loop that it starts at the last end and then it goes down to one. We'll go down to one, and each time it'll go down by one until it gets to one. um, then here we check. This is where we check if they have a common divisor. So if last int is divisible by x and first int is divisible by x, that means they're both divisible by, and this is mod x. So mod x, if it this means so this mod x that gives you, so if you, so this is like 10, and say this is last int is 10, which it won't be, but whatever, and this is 5, um, that gives you the remainder. So 10 divided by 5 is 2 with a remainder of 0. So this would return 0. So this would be true. Um, so yeah, so if these equal 0, that means that if these both equal 0, that means they both have something that that are both divisible by. They have a common divisor. So that means it's not coprime. So we set is coprime to false. And then we break the for loop. Um, and yeah, we go down here. If is coprime, then it's not gonna be, and then it's gonna go on. If it never does this, if it's never coprime, then this will be true. And once this for loop is over, it will increase beautiful pairs by one. All right. So then this is else. This is the same thing, just with the last, if the last int is bigger, or if they're the same. Um, in which case, if they are the same, then they won't. They will be the biggest common divisor will be themselves. So yeah, so it won't be coprime, so it won't be a beautiful pair. That won't be a beautiful pair. Otherwise, it'll start at the last int. No, it'll start at the first int and go through them all. And then if it's coprime, it will increase the beautiful pairs. And then this is all within this is all within the two for loops. So once the two for loops, that goes through all the pairs, basically goes through all of the possible pairs. Um, Once that's done, it returns the number we have, the number of beautiful pairs. I'm trying to, okay, so yeah, I think here, at either of these, so if, um, yeah, well, yes. If last int is 0, because like I'm thinking back to when they said 0, like 10, there's not going to be a 0 at the end. If this was 0, 0 mod something, it would return something. Um, I don't know, would return, yeah, 0 mod, but yeah, but okay, see, if it was 0, then this x could have been 0, and then something divided by 0 is going to make the whole program panic. So that's unfortunate that that was there. Um, I think you probably could have done a test. Could have done a test somewhere. If one of the numbers was 0, like even if one of the numbers was 1, you could say, okay, well that's not going to be a beautiful pair because it's because the greatest common denominator, the only thing it could be is 1. And you can check for 0. If it's 0, you could have thrown an error. So, like I said, I'm really lucky that it didn't allow zeros. That would have broken my thing. But fortunately, I didn't have any bugs this week, so that's nice. We'll take that W. Um, so yeah, we run this. I haven't actually run this with these specific numbers yet. So we should okay. We got 13 in this one. Wow. 13 beautiful pairs in this nice, beautiful array. So that is the beautiful pairs. Then this one, I'll read it, see if you guys can do it, but I couldn't really. All right, I'll get okay. Um, you are given two integers, num1 and num2. In one operation, you can choose integer I in the range 0 to 60 and subtract 2 to the power of I plus num2 from num1. Return the integer denoting the minimum number of operations needed to make num1 equal to 0. If it is impossible to make num1 equal to 0, return -1. Um, okay, num1 can be any number 1 to a super big number. Num2 can be any number from like almost any number, negative or positive, that Java can handle basically. So um, I basically get, so I can see, I can understand. So this says, so you have to, you pick a number 0 to 60 for I, and then it gives you num2. So you see how you can change I and keep subtracting the number you get from this operation from num1. How many times you have to do that to get to 0? The minimum number of times. That kind of makes sense. Like maybe as a puzzle I could work it out, but I have no idea how I would program this. Um, I even tried looking after the contest was done. I looked at other people's submissions, and they used like specific uh they used like stuff I've never used. Like 10 or 19, sorry. This equals 3, except I think um 19 wasn't like a int x. Yeah, I don't know. So or it changes it. Okay, yeah, okay. It was like something like x equals 2, and then we have x, bam. Yeah, it was something like this. I don't know what this does. I don't know what this operation does. It changes x. I think it's like a shorthand, kind of like how I plus, x plus plus. It would x plus plus would make 2 to 3. So, but I don't know what this operation does. And I saw a lot of people using stuff like that, and I didn't know. So I think I need some more classes to figure that part out. Um, but if you guys can figure out how to do it and maybe explain how to do it, hit me up, say, hey, Blue Thunder, I figured it out. Just here, just go check out my video, and maybe I'll check it out. Give you a shout out. Um, but I don't know. It's a bit too much. Because okay, here's the issue. See, even here in this, so it goes subtracts, does the operation with a 2, and so it gets a 1. Then it does another 2, and it takes it to -1. And then it uses a 0, and it gets it back up to 0, which is like, so it goes down the number line, it goes past 0, and it goes back to 0. And it's like, how do I code that? Like I could hard code it, you know? Um, but I don't know how I would know when to check, um, when to use the I, like I. And then I also saw people like multiplying num2 by I. It's like, how does what? How is that gonna do anything? I'm sure they did it right. They got the solution, but I don't know. I don't know how that would be involved. So this one's a tricky one. Um, like, see, because I misunderstood a couple parts at the beginning, so I got started with it, but I never, I couldn't figure it out. I kind of wish that I started working on this one. I feel like I bet I could have done this one. You got to split it, so you got some arrays with only one in each of them. Um, see, it can get a little weird, but um, yeah, yeah, I don't. I probably could have done this one, but it's too late now. Um, Lesson learned. Check all the problems before you get started, and make sure you read them all. Read it fully before you get started, before you run into mistakes. But um, yes, that was this week. 351. I hope you guys gained something from this experience. And I hope you guys had a good week, and I hope you have a good future week this coming week. And I'll probably see you guys next week. Yeah, all right. Have a good day. Bye.